Thermodynamics Test Questions Set Number 7. Question 1. Quasi-static process. A. Is infinitely slow process. B. Experiences thermodynamic equilibrium at every small point on its path. C. Reversible process. D. All of the above.
Answer: all of the above. Explanation: consider a system of gas exists in a cylinder. The piston consists of many very small pieces of weights. Initially, system is in an equilibrium state. When the gas system is isolated, the weights on piston are removed one by one slowly, at any instant of upward travel of the piston. So every state passes through by the system will be in an equilibrium state. Thus the system passes through the locus of all equilibrium points. This infinitely slow system is a quasi-static process. If the same small weights are now placed slowly one by one on top of the piston, then the process will reverse in the same manner.
Question 2. The thermocouple circuit which is used to measure temperature works on, fill in the blank. A. Seebeck effect. B. Peltier effect. C. Thomson effect. D. None of the above.
Answer: Seebeck effect. Explanation: the Seebeck effect states that when two ends of a thermocouple are kept at different temperatures, then the EMF is generated in the circuit depending on the temperature difference between the hot and the cold junction. Therefore EMF is a thermometric property of the circuit. The thermocouple is calibrated by measuring the thermal EMF at various known temperatures, the reference junction being kept at 0 degrees Celsius. Peltier effect is exact opposite of Seebeck effect, that the temperature difference is created by applying the voltage between two junctions of thermocouple circuit.
Question 3. Heat is transferred across a boundary by virtue of a temperature difference. The heat is transferred, that means A. Force transfer takes place. B. Energy transfer takes place. C. Temperature transfer takes place. D. All of the above.
Answer: energy transfer takes place. Explanation: when a system changes its state from state 1 to state 2, the work involved depends upon the path through which the system undergoes change. For consistency with the principle of conservation of energy, some other type of energy transfer along with work transfer must have taken place between the system and surrounding. This type of energy transfer is occurred by virtue of a temperature difference. This energy is called as heat.
Question 4. Total amount of energy in the universe is A. Increasing. B. Decreasing. C. Constant. D. None of the above.
Answer: constant. Explanation: the first law of thermodynamics states that the energy can neither be created nor be destroyed. It can only get transformed from one form to another form. The universe consists of the system as well as the surrounding together. Energy can only be transferred from system to surrounding or surrounding to system in various forms, but it can never be destroyed or created. Thus the total amount of energy in the universe is constant. We cannot produce a device which can supply mechanical work without consuming any energy.
Question 5. To achieve a definite 0 point on the Kelvin scale, we have to violate A. First law of thermodynamics. B. Second law of thermodynamics. C. Both first law and second law of thermodynamics. D. No law has to be violated.
Answer: second law of thermodynamics.
Question 6. The temperature at which a system undergoes a reversible isothermal process without transfer of heat is called as, fill in the blank dash. A. Critical temperature. B. Kelvin temperature. C. Absolute zero temperature. D. Reversible temperature.
Answer: absolute zero temperature.
Question 7. Any attainable value of absolute temperature is, fill in the blank dash. A. Always less than 0. B. Always equals to 0. C. Always greater than 0. D. None of the above.
Answer: always greater than 0. Explanation: it is impossible for a system to undergo a reversible isothermal process without transfer of heat. To make this process possible, the temperature required is an absolute zero temperature, and the second law of thermodynamics is also violated. Thus any attainable value of absolute temperature is always greater than 0. This is also called as third law of thermodynamics. It states that it is impossible for any process to reduce any system to an absolute zero temperature in a finite number of operations.
Question 8. Assume that a reversible heat engine is operating between a source at T1 and a sink at T2. If T2 decreases, the efficiency of the heat engine, fill in the blank dash. A. Decreases. B. Increases. C. Remains constant. D. None of the above.
Answer: increases.
Question 9. The irreversibility in the system caused by friction is an example of A. Internal irreversibility. B. External irreversibility. C. Frictional irreversibility. D. Chemical irreversibility.
Answer: internal irreversibility. Explanation: all the spontaneous processes are irreversible in nature. The irreversibility is caused by finite potential gradient like temperature gradient etc., or by any dissipative effect like friction. There are two types of irreversibility. I. Internal irreversibility. E. External irreversibility. Internal irreversibility is caused by internal dissipative effects in the system like friction, turbulence, electric resistance etc. Thus the irreversibility in the system caused by friction is an example of internal irreversibility.
Question 10. When a process becomes irreversible due to heat interaction between system and surrounding at the boundary due to finite temperature gradient, then the irreversibility is, fill in the blank dash. A. Internal irreversibility. B. External irreversibility. C. Mechanical irreversibility. D. Chemical irreversibility.
Answer: external irreversibility. Explanation: all the spontaneous processes are irreversible in nature. The irreversibility is caused by finite potential gradient like temperature gradient etc., or by any dissipative effect like friction. There are two types of irreversibility. I. Internal irreversibility. E. External irreversibility. The external irreversibility occurs due to the temperature difference between the source and the working fluid at heat supply and the temperature difference between the sink and the working fluid at heat rejection. If the hypothetical heat source and sink is considered, then the process becomes reversible.
Question 11. The degree of disorder of a mixture of two gases. A. Is always less than the degrees of disorder of individual gases. B. Is always greater than the degrees of disorder of individual gases. C. Is always equals the degrees of disorder of individual gases. D. None of the above.
Answer: is always greater than the degrees of disorder of individual gases.
Question 12. What is the relation between thermodynamic probability W and entropy? A. Thermodynamic probability increases with entropy. B. Thermodynamic probability decreases with entropy. C. Thermodynamic probability does not change with change in with entropy. D. None of the above.
Answer: thermodynamic probability increases with entropy.
Question 13. At the most probable state of a system, the entropy of the system is A. Minimum. B. Maximum. C. Constant. D. None of the above.
Answer: maximum.
Question 14. Which device used to separate condensate from the steam without letting steam escape? A. Condenser. B. Steam valve. C. Steam trap. D. None of the above.
Answer: steam trap.
Question 15. At the state of perfect order W equals 1 of pure crystalline substance, how is the zero entropy defined? A. Entropy at 0 degrees Celsius temperature. B. Entropy at absolute zero temperature. C. Entropy at the freezing point of the substance. D. None of the above.
Answer: entropy at absolute zero temperature.
Question 16. What is the reason behind the fact that the absolute zero entropy value is not attainable? A. Because absolute zero temperature is not attainable in finite number of operations. B. Because theoretically absolute zero temperature has negative value of entropy and it is not possible. C. Both A and B. D. None of the above.
Answer: because absolute zero temperature is not attainable in finite number of operations.
Question 17. What is the entropy chosen at the triple point of water? A. 0. B. Less than 0. C. More than 0. D. None of the above.
Answer: 0.
Question 18. What is the difference between work done by a system through an ideal reversible process and actual work done by the system called? A. Irreversibility. B. Degradation. C. Dissipation. D. All of the above.
Answer: all of the above.
Question 19. Which will be a suitable condition of exergy loss and entropy generation for thermodynamically efficient process? A. Maximum exergy loss with minimum rate of entropy generation. B. Minimum exergy loss with maximum rate of entropy generation. C. Maximum exergy loss with maximum rate of entropy generation. D. Minimum exergy loss with minimum rate of entropy generation.
Answer: minimum exergy loss with minimum rate of entropy generation.
Question 20. What is the value of exergy in general? A. Only negative. B. Only positive. C. Sometimes positive, sometimes negative. D. Cannot say.
Answer: only positive.
Question 21. What is the dryness fraction X on saturated vapor line? A. X equals 0. B. X equals 1. C. X equals 0.9. D. X equals 0.5.
Answer: X equals 1.
Question 22. What is the line which starts from critical point having constant dryness fraction throughout the line as shown in figure line 1 called? A. Constant vapor line. B. Constant liquid line. C. Constant quality line. D. None of the above.
Answer: constant quality line.
Question 23. In a mixture of ideal gases of volume V and temperature T, what is the pressure exerted by each individual gas if it occupies the total volume V alone at temperature T called? A. Individual pressure. B. Divided pressure. C. Partial pressure. D. Total pressure.
Answer: partial pressure.
Question 24. What is the entropy change when the system is at stable equilibrium state? A. The entropy change will be positive. B. The entropy change will be negative. C. The entropy change will be 0. D. Cannot say.
Answer: the entropy change will be 0.
Question 25. What is the entropy of the system at equilibrium state? A. 0. B. Minimum. C. Maximum. D. Constant but not maximum.
Answer: maximum.
Question 26. A closed feedwater heater system. A. Has high heat transfer capacity. B. Requires pump at each heater to handle the large feedwater stream. C. Requires only single pump regardless of the number of heaters. D. Does not require any pump as the extracted steam and feedwater are not allowed to mix.
Answer: requires only single pump regardless of the number of heaters.
Question 27. What is the drawback of the steam as a working substance in a power cycle? A. In a vapor power cycle, maximum temperature which can be obtained with best available material is more than the critical temperature of water and requires large superheating. B. It allows only small amount of heat addition at the highest temperature. C. It requires reheat and reheater tubes are costly. D. All of the above.
Answer: all of the above.
Question 28. As the heat rejection temperature decreases in the vapor power cycle below atmospheric pressure, A. The vacuum in the condenser also decreases. B. The vacuum in the condenser increases. C. It does not produce any vacuum in condenser. D. None of the above.
Answer: the vacuum in the condenser increases.
Question 29. What should be the critical temperature of working fluid for maximum efficiency of vapor power cycle? A. The working fluid should have critical temperature as low as possible. B. The working fluid should have critical temperature as high as possible. C. The critical temperature does not affect the efficiency of the vapor power cycle. D. None of the above.
Answer: the working fluid should have critical temperature as high as possible.
Question 30. The specific heat of the ideal working fluid used in vapor power cycle. A. Should be constant. B. Should be large. C. Should be small. D. None of the above.
Answer: should be small.
Question 31. What is the importance of the freezing point of the working fluid in the vapor power cycle? A. Freezing point of working fluid should be below the room temperature. B. Freezing point of working fluid should be above the room temperature. C. Freezing point of working fluid should be equal to the room temperature. D. Does not have any importance.
Answer: freezing point of working fluid should be below the room temperature.
Question 32. When two vapor cycles are coupled in series and heat rejected by one is absorbed by another, the cycle is called as A. Dual vapor cycle. B. Binary vapor cycle. C. Coupled vapor cycle. D. None of the above.
Answer: binary vapor cycle.
Question 33. In working condition of turbojet engine, velocity of air entering the engine is A. Higher than the velocity of exhaust gases leaving the engine. B. Lower than the velocity of exhaust gases leaving the engine. C. Equal to the velocity of exhaust gases leaving the engine. D. Cannot say.
Answer: lower than the velocity of exhaust gases leaving the engine.
Question 34. Why do the airplanes fly at higher altitude during the long flights? A. To avoid collisions as they are at very high speed and controlling will be difficult if something like towers, hills comes in the way. B. It is easy to communicate with satellites at high altitudes. C. To save the fuel as air at higher altitude exerts smaller drag force on aircraft. D. None of the above.
Answer: to save the fuel as air at higher altitude exerts smaller drag force on aircraft.
Question 35. The propulsive efficiency is the ratio of A. The propulsive power to the energy input rate. B. The exit velocity rate of exhaust gases to the energy input rate. C. The work done by the turbine to the energy input rate. D. Velocity of aircraft to the energy input rate.
Answer: the propulsive power to the energy input rate.
Question 36. In turbofan engine, fan is used. A. To compress the inlet air more efficiently. B. To increase the total thrust of the engine. C. Both A and B. D. None of the above.
Answer: to increase the total thrust of the engine.
Question 37. In turbofan engine, the bypass ratio is the ratio of A. Total mass flow rate of exhaust stream to the mass flow rate of stream from turbine exhaust. B. Total mass flow rate of exhaust stream to the mass flow rate of stream from fan exhaust. C. The mass flow rate of stream from turbine exhaust to the mass flow rate of stream from fan exhaust. D. The mass flow rate of stream from fan exhaust to the mass flow rate of stream from turbine exhaust.
Answer: the mass flow rate of stream from fan exhaust to the mass flow rate of stream from turbine exhaust.
Question 38. What is the effect of increasing bypass ratio of a turbofan engine on its thrust? A. Thrust increases with increase in bypass ratio of turbofan engine. B. Thrust decreases with increase in bypass ratio of turbofan engine. C. Thrust of the turbofan engine only depends upon the fuel rate, so no change of thrust with increase in bypass ratio. D. Cannot say.
Answer: thrust increases with increase in bypass ratio of turbofan engine.
Question 39. Heat pump is used. A. To transform low-grade rejected heat into high-temperature heat source. B. To transform high-grade rejected heat into low-temperature heat sink. C. Both A and B. D. None of the above.
Answer: to transform low-grade rejected heat into high-temperature heat source.
Question 40. Which of the following is not a type of heat pump? A. Vapor compression type. B. Vapor absorption type. C. Both A and B. D. None of the above.
Answer: none of the above.
Question 41. In year-round air conditioning, by reversing refrigerating cycle. A. Condenser acts like evaporator. B. Evaporator acts like condenser. C. Both A and B. D. None of the above.
Answer: both A and B.
Question 42. In gas cycle refrigeration system, the throttle valve of a vapor compression refrigerant system is replaced by A. Capillary tube. B. Expander. C. Reverse throttle valve. D. None of the above.
Answer: expander.
Question 43. How much is the temperature drop of real gas by throttling? A. Very big temperature drop. B. Very small temperature drop. C. No temperature drop. D. Cannot say.
Answer: very small temperature drop.
Question 44. The ideal gas refrigeration cycle is similar to A. Brayton cycle. B. Reversed Brayton cycle. C. Rankine cycle. D. Reversed Rankine cycle.
Answer: reversed Brayton cycle.
Question 45. The horizontal line in psychrometric chart joining the change of state of air represents A. Humidification. B. Sensible cooling or heating. C. Sensible cooling or heating with humidification. D. Sensible cooling or heating with dehumidification.
Answer: sensible cooling or heating.
Question 46. Humidification is the process of addition moisture in air at A. Constant wet bulb temperature. B. Constant dry bulb temperature. C. Constant latent heat. D. None of the above.
Answer: constant dry bulb temperature.
Thanks for watching. Please comment, like and share.